Next topic is chemical equation. So what is chemical equation? Why it is necessary? See, it is the symbolic representation of chemical reaction in the form of formula and symbol, that is known as chemical equation. We will see the example. You consider activity 1. What's a chemical reaction? We have seen magnesium reacts with oxygen present in the air and it produces magnesium oxide, right? So it is a sentence form. It is too long, right? So we can write it shortly by using chemical equation. We will see how. Okay, first we will see the word equation. Word equation for activity 1. Magnesium reacts with oxygen present in the air, right? So here reactants are magnesium and oxygen. We have to write magnesium plus oxygen. Then we have to write arrow mark. What's the product? Magnesium oxide. Magnesium oxide we have to write. This is the word equation. This word equation again it can be written into chemical equation by using its symbol and formula. You see the word equation magnesium plus oxygen. So what's the symbol of magnesium? It's Mg. What's the symbol for oxygen? O2. So Mg plus O2. These two are reactants. Arrow. Then what's the product? Magnesium oxide. So what's the formula of magnesium oxide? It is MgO. So this is chemical equation for activity 1. Similarly, can you able to write the chemical equation for activity 2 and 3? Yes, you try. See, while writing the chemical equation, we have to follow certain rules. Okay, which are those? We will see. The reactants are written on the left hand side with a plus sign and the products are written on the right hand side with the plus sign between them. You see the above equation. Activity 1. Reactants are magnesium and oxygen. So Mg plus O2. If one more reactant is there, plus that reactant. Okay, left hand side. And the product on the right hand side. Here it is MgO. One more product is there, plus that product we have to write. Then the second one. Arrow between the reactant and product shows the direction of the reaction, whether it is forward reaction or backward. See, here it is forward reaction. Okay. Next, the third one. Upward arrow indicates liberation of gas and the downward arrow indicates formation of precipitate. For example, in the activity we have seen hydrogen gas is liberated. We have to write like this H2. If it is oxygen, we have to write like this O2. Similarly, downward arrow, what it indicates? It indicates formation of precipitate. We have seen in the activity 2 formation of precipitate, right? Lead iodide. If it is the case, then we have to write like this downward arrow. It indicates formation of precipitate. Okay. The next one. The physical state of reactant and products are written as S for solid, L for liquid, G for gas, aqueous. If the reactant is prepared by using water, then we have to write AQ. Okay. See. Here it is magnesium solid, oxygen, gas, magnesium oxide. Again it is solid. We have to write like this. Okay. Hope you understood all the rules. Okay. Fine. Next topic is balanced chemical equation. See why we have to balance the chemical equation. What is a balanced chemical equation? To know more about this, first we will study law of conservation of mass. What it says? See, mass can neither be created nor be destroyed in a chemical reaction. This is the law. Okay. So to obey this law of conservation of mass, we have to balance each and every equation. Okay. Then what's the meaning of this law? See. the total mass of each element present in the reactant side, it should be equal to total mass of element in the product side. This is the meaning. For example, if mass of the hydrogen atom in the reactant side, it is 2. In the product side also it should be 2. If it is 4 in the reactant side, product side, it should be 4. That is the meaning. Okay. So the total mass of the reactant should be equal to total mass of the product, or mass of each element present in the reactant side. You see here, each element present in the reactant side should be equal to total mass of element in the product side. Okay. In other words, we can say that number of atoms of each element in the reactant and product side remains equal. If this is the case, then we can say that the equation is balanced, and such equations is called balanced chemical equation. Okay. If it is not balanced, for example, in the mass of hydrogen you consider, in the reactant side it is 2, in the product side if it is 4, then it is not balanced, right? Such equations are called as skeletal equation or unbalanced equation. Okay. Then how to balance this equation? To balance the equation, we have to follow certain rules. If we know the rules properly, then we can balance the equation. Then what are the rules? We will see. The first rule, find the correct formula for all reactants and products. For example, if it is activity 1, magnesium reacts with oxygen present in the air and it produces magnesium oxide. We have to find the correct formula for reactant, magnesium and oxygen. It is O2. And magnesium oxide, it is MgO. That we have to find first. Next, write the formula of reactant on the LHS and the product on the RHS. Write the correct formula of the reactants in the left hand side and the product on the right hand side. Next, list the different element appears on left hand side and RHS of the equation. For example, if it is the activity 1, what are the elements present? Magnesium reacts with oxygen, right? So magnesium, oxygen and magnesium oxide. These three we have to write. And count the number of each element on LHS and RHS. In the reactant side, how many magnesium are present, we have to write. In the product side, how many are present, that we have to write. Okay. Then start the balancing with the compound that contains maximum number of atom. It may be reactant or product. For example, you consider the equation. In that equation, iron oxide Fe3O4 is the highest number of or we can say that maximum number of atoms. Okay. This is the case. We have to see, you see this Fe3O4. Here oxygen present, how many oxygen are present? 4. Iron it is 3, right? So you start the balancing with oxygen atom. Why? Because in this compound, select the element which has maximum number of element. In this case it is oxygen, right? So we have to start with oxygen. Next, to equalize number of atoms, do not alter formula of the compound. This is very important. You consider the same example here, Fe3O4. Here 3 iron atoms are present, right? You have to make it 6. Okay, while balancing you have to make it 6. Means don't strike off this 3 and write 6. This is the not correct way. If you have to make it 6 means how we have to do? We have to multiply this entire term by 2. Now 2 into 3. it becomes 6. We have to multiply here. 2 into 3, it becomes 6, right? This is the correct way to balance. Next, write the symbol of physical state. One more example we will consider. H2. Here 2 hydrogen atoms are present, right? If we have to make it 4 means don't write 4 here. You have to write 2 here. 2 into 2, it becomes 4. Okay, this is the correct way. Next, write the symbol of physical state. For example, solid, you have to write S. For liquid, you have to write L. And for gas, we have to write G. Okay, this is the rules. Understood?